Do it. Hi, everyone. I've already met most of you. For those who don't know, I'm Michael. And I'm going to be talking to you about the artist and the machine. In this case, the artist you see here is Desmond Paul Henry. He's an artist from Manchester in England who, in the 1960s, took analog computers out of World War II bomber planes, computers like you see right here, and he repurposed them into machines which generated some of the earliest examples of computer art. And we'll see some of the results of that later. When I was in my early teens, I had quite a big illicit MP3 collection. And I used to use Winamp to listen to it. Anyone else out here did that? All right. Okay, everyone. OK, good. So you know there was these really cool visualization plugins that you could get, right? This is Milk Drop by Ryan Geis. So back in the day when I saw these, I was just blown away by this stuff. And I really, really wanted to know, how do you do it? But I had no clue. 20 years later, give or take, I'm just starting to figure it out. So today I want to talk about creative coding. So let's first define it, because programming is inherently a creative task, right? I mean, we have business requirements, we have problems to solve, we need to engage our creative facilities to solve these problems. So is not all programming creative coding in some way? Well, yeah, kind of, but I'm talking about a little bit different today. So creative coding is a type of computer programming in which the goal is to create something expressive instead of something functional. So the key point is that in your day jobs, the creativity that you use is a means to an end, whereas with creative coding, it is the end itself. Another way to say it is that it doesn't matter whether it works or not. So what's not to like about that? Some examples of artists that I like. This is a short talk. This is a lightning talk, 15 minutes, so I've got to be pretty fast. I can't do a really in-depth presentation, but I just want to share a few ideas, show a little bit of code, and hopefully inspire some of you to explore the creative side. Just a note before we go further about maths. I call it maths with an S because I'm from England. And you might see these last slide and think, oh, it looks cool, but don't you have to be really strong at maths to do this kind of stuff, this graphics work, right? I'm just a regular developer. I'm struggling here to center vertically align a div. Yeah, you feel the pain. And yeah, I'm sure that being really good at maths would be a massive help. I don't know myself because I'm not really good at maths. My level of maths knowledge is strictly high school. We're talking BODMAS, SOHCAHTOA, this kind of stuff. But the thing is, it's OK. To get started, you don't need more than that. So there's no barriers to entry, OK? I hope to show you that in this talk. So with that, let us begin. Dramatic pause. From our earliest origins, we have sought to express ourselves creatively. First of all, we've probably got sticks, pointy sticks, making lines in the sand. Maybe we got some charcoal, put it on a wall. At some point in the distant past, someone invented the paintbrush, very versatile tool, still in use today. But artists tend to be a restless kind of people, and some artists said, paintbrush is not enough, we need more. This is Max Ernst. He was an artist who did use a paintbrush, but he also did things like this, which he describes thus, quote, tie a piece of string 1 or 2 meters long to an empty tin can, punch a hole in the bottom and fill the tin with paint. Then lay a canvas flat on the floor and swing the tin backwards and forwards over it. The results of which look like this, 1942, and this. The interesting thing to note is that in his description is basically a series of instructions on how to do it. Another name for a series of instructions is algorithm. So in some very loose sense of the word, you could say this is an early example of algorithmic art. And it should come then as no surprise that the results of this method do bear some resemblance to actual algorithmic art that you can make on a computer. In particular, take a look at these two figures. Interesting. All right, let's look at this further. These figures are known as Lissajous curves, and the equations which describe them are actually really simple. The x-coordinate is sine a times t, y-coordinate is sine b times t. T is just some increasing parameter. A and b are constants which define the shape of the curve, as you can see in the grid. It's understandable, okay? Yeah? Do you agree? It's understandable. It's not too hard. So this is a good time to let's dive into some code. Okay. Is this the first live coding we've had? No? Oh, okay. Anyway, this is live coding. So please support me. Please call out my mistakes. So the important thing to know is here on the right is just a canvas. It's blank right now. It's black. Nothing happening. On the left is the code. We're using the HTML5 canvas. This is the context. Don't need to worry about that too much. But we have our constants a and b defined. We have a for loop, and this is where we get our parameter t. So we're just going to implement this simple equation now. So let's say x is a. OK. And then we can say b times t for y. And then if we're on the first iteration, I guess I should do that. Let's begin a path. Don't worry too much about the details if you're not familiar with the Canvas API. It's not really the point. And otherwise, let's do, no, I don't want that. I want a line 2. And then we just plug in the coordinates. And we give it a radius to make sure it's big enough to see. OK, and then at the end of it all, we just call stroke, which is like draw the line. All right, moment of truth. Let's refresh this. OK, it worked. So you can see this is simple, right? We made this Lissajous curve. Thank you. It gets better. It gets better. Did you know computers are more powerful than a tin of paint on a string? I will prove it to you right now, because I was kind of sneaky in the last slide with the equation. I missed off a secret parameter. And we can call it anything we want. Let's call it magic. And let's define it thus. And all I'm going to do is plug it in here. I'm going to add it on here, add some magic. All right, now, Max, what do you think of this? OK, it worked. OK, thank you. So you can see it's simple to start. You can make something that kind of looks nice, looks pretty cool. It's not hard. Let's make it a bit more sophisticated now. Let's go back to Desmond Paul Henry's drawing machines. This is one of them, a detail. He made 3 altogether. And the kind of results you got were like this. Yeah, I mean, this is like 1960s. Real paper. And I know some of you are probably thinking, wow, this looks really cool, but somehow familiar. And that's right, because you know what Desmond Paul Henry basically did was he just made it a super fancy Spirograph. Anyone played with one of these? OK, good. This is going to go well. So Spirograph is really interesting because it's an example of generative art or algorithmic art. And this is the kind of thing where you have some well-defined rules, and you apply these rules usually over and over again, and it generates something that looks nice at the end of it. And for me, this is a really interesting paradigm because it raises a question, which is this. Who's the artist? Is it these kids? Are they the artist? Or is it Dennis Fisher, the guy who invented the Spirograph? Or is there some kind of artistic continuum or spectrum that exists between the two? I'm not going to answer this, but it's just interesting to think about. So for those who don't know, this is how a spirograph works. You have a large circle, and a small circle rotates in the middle of it and draws out a path. Another way you could think about this is you could think of it as 2 rotations superimposed. So we have one rotation here, and then another rotation is superimposed on top. And let's experiment a little bit with this idea now. OK, back to some code. So, boop. All right. We have here a new file. Now, I've not got time to go into all the kind of supporting code here, because it's such a short talk. But the important part is this function here, circle point, where we give it a midpoint in the middle of the canvas here, a radius and an angle, and then we just use the sine and the cosine, and this describes the circular shape. So this is a circle. So the idea is we want to superimpose two circles. So we could do something like this. We could call this one point 1. And then we could use that point as the midpoint for the next circle. It's a simple idea. And then we'll change the radius and the angle just to add some variation. So let's do this. OK, and so in theory, this should kind of look somewhat spirograph-like. Yeah, I think it looks pretty spirograph-like. We can mess around with these and get different kinds of results. OK. But did you know that the computer is even more powerful than a spirograph? Because I'm going to show you something now that you can never do on a spirograph, a physical spirograph. And that is to superimpose 3 circles, one on top of the other. And it's so simple on a computer. You can just say, OK, let's call that point 2. And let's use that point as the basis of the next one. No, what am I doing? There we go. And you end up with something like this. OK, show me a spirograph that can draw that. And then for me, the real like joy of this kind of stuff is just playing around with these numbers here. So we could, let's say, OK, vary this a little bit. And then you get these kind of radically different and unexpected outcomes. And going back to the original quote about it's got no real functional purpose, but it's purely aesthetic, purely creative. So you can't go wrong. You can't make a mistake. No, you're not going to lose any money. No one's going to get in trouble. You can just play with it. And you can't mess it up. There's only happy accidents for those Bob Ross fans out there. Yeah, so you do stuff like this. And so for me, as I say, the joy is just you mess around with this stuff. And while I was preparing this talk, I played around with this a little bit. And I'm going to fast forward because I've not got time to live code all this. So get to the rescue. And I want to show you just some way you can take this with a little bit more time. So something like this. I mean, it's a little bit more code. I can't explain it all now, but it's really easy to arrive at something that looks kind of cool. My intention was to have this as an audio visualization to some music, but technical reasons didn't allow that. But yeah, this is just dipping our toes into the pool of creative coding right now. There's a whole ocean. I encourage you to go and take a dive, swim around in it. It's good fun. OK, so to conclude, you can catch these slides up at this URL. Yeah, everyone, get your phone out right now. Some of you might wonder, like, what's this program I'm using to show these visualizations? I'm actually working on a JavaScript kind of, I'm trying to recreate Milk Drop with JavaScript. So this is a project I've got going right now. Download it. It's beta. It's kind of buggy. But you might be interested. And here's a list of resources, learning, and finding out more about the subject. My name is Michael. This is my Twitter handle. You can follow me, and I post like sketches and doodles from time to time. Thank you very much.
Thank you very much, Michael, for the fantastic talk. While next speaker is getting prepared and mic'd up, maybe we can do one question, Michael.
Oh, question, OK.
One question that I have is, how did you get started with this? What was your intention?
Intention?
Oh, how did you get started with this? How did you come up with this?
It's easier. Well, as I say, like, back in the day, I saw these kind of things. I have a kind of a traditional art background, and then I got into computers later. And for me, it's the possibilities of what computers allow is just mind-blowing. I mean, you can do a lot with a canvas, and you can do a lot with paint, but what you can do here, and you don't get your hands dirty, it doesn't smell. Yeah, It's just, I like to sit down and play with this stuff.
Cool. Thanks, Michael.
Thank
Please
you.
make some noise for Michael Bromley.